Welcome back to the video series on integration and differential equations. In today's video, we're going to help you know your derivatives. Derivatives come up in almost every integration problem, so you want to know your derivatives really well. We're going to run through 17 functions and their derivatives. So I'm going to make a table here. I'll just list the function f of x on the left side, and on the right side we can write down its derivative f prime of x. Why don't we start with some powers of x? Derivative of x to the negative 2 would be negative 2 x to the negative 3. And we could try that with a fractional exponent. Let's say we had x to the 4/3. The derivative would be 4/3 x to the 1/3. Next, let's move on to the trig functions. So if f of x is sine x, then the derivative is going to be cos x. And if we started with cos x, the derivative would be minus sine x. So I find it helpful to notice that sine x and cos x are partners in the following sense. When you take their derivatives, you're getting something else that involves cos x or sine x in some combination. None of the other trig functions come into the discussion. And we're going to see the same kind of pattern as we run through the other 4 trig functions. So let's say we started with tan x. The derivative of tan x is secant squared x, and the derivative of secant x is secant x tan x. So again, you could say tan x and secant x are partners in the following sense. Their derivatives only involve tan or secant. The derivatives don't involve any of the other trig functions. And then finally we come to the last 2 trig functions. Derivative of cosecant x is negative cosecant x cotangent x, and derivative of cotangent x negative cosecant squared x. So again, you could say that cosecant and cotangent, those are partner functions. You could also point out that both of those derivatives are negative. So both those things help me in remembering the derivatives. Now often we run into these functions in combination with the chain rule. So if we wanted to take the derivative of, say, sine 2x, we'd say, well, the derivative is cos 2x times the derivative of the inside function. So we'd need to multiply by 2. If we wanted to take the derivative of, say, secant x cubed, the derivative would be secant x cubed tan x cubed, and then times the derivative of our inside function, which is 3x squared. So that's 10 functions down, 7 more to go. Let's make another set of columns here, and we're going to start with the inverse trig functions. So let's say we run into arc sine x. I would point out you could write that either way. So arc sine x, the derivative is going to be 1 over the square root of 1 minus x squared. If we were working with arc cos instead, the derivative is very similar. It's just the negative version of what we had above. So negative 1 from the square root of 1 minus x squared. And arc tan x, oops, I'm going to leave a little bit more space here actually, so that this doesn't get too cluttered. So arc tan x, if that's our f of x, then f prime of x would be 1 over 1 plus x squared. So those are our inverse trig functions. Now, let's say we run into ln of 2x plus 1. To differentiate ln, you're putting the inside function on the bottom and the derivative on top. So if f of x is ln of 2x plus 1, the fastest way to think about f prime of x is that you've got that function 2x plus 1 in the denominator, and then the derivative of that function, which is 2, goes into the numerator. More generally, if we had ln of some function, let's call that function g of x, then we'd have g of x on the bottom and g prime of x on top. So g prime of x over g of x. Okay, moving on to the exponential functions. If f of x is e to the 7x, the derivative would be e to the 7x times the derivative of whatever's sitting in the exponent, so overall 7 e to the 7x. Or if we do that one more generally, let's say f of x is e to some function, e to the h of x, let's say, then the derivative is going to look like e to the h of x times the derivative of that exponent. So we'll multiply by h prime of x out in front here. So those are 17 functions and their derivatives. In my mind, there are two secrets to successful integration. The first secret is really knowing your derivatives well. For me, flashcards are the best way to learn something like derivatives, so hopefully those might work for you. So that was our first secret, know your derivatives. And second secret to successful integration, practice, practice, practice. All right, we'll see you in the next video.